Hello, I am Jonathan Roberts. Today is Monday, March 23rd. I am a founder and a partner in a venture capital firm in Seattle called Ignition Partners. As part of, and prior to that, a former Microsoft executive. As part of that, I'm very well connected into the local tech community in the Seattle area. And it was through that relationship that I connected with Korathu-Larson. And Korathu-Larson is essentially a 3D printing savant who was tracked down by Kaiser Permanente out here to help them make masks and visors in order to respond to the incredible shortage of both of those devices. Rory has designed a 3D printing CAD that allows the mask to be produced in 3.5 hours and from generally commercially available parts. And so it is our hope that these devices can be created by 3D printers and hobbyists throughout the country and potentially around the world with parts they have at hand to help address this incredible need. We're creating one such facility in Seattle this week that we hope can produce upwards to 300 masks a day. So with that, I will toss this over to Rory to provide a description and show you the mask. I want to note a significant caveat, which is this mask is currently in trial at Children's Hospital in Seattle. There are 7 of them there today being used by physicians. They are also running a test of the mask to test both its usability and its efficacy through a variety of different CDC-approved methods. We will have that information and validation within probably 2 days. So, and we'll do an updated video at that point in time. So now I introduce to you Korathu-Larson.
Hi there. So this is the respirator that's I've designed. It is essentially almost all 3D printed and snap fit, although some glue can be used for seals and seams. But otherwise, it is made entirely out of 3D printed and easily commercially available parts. The soft rim around here is actually weather stripping from Home Depot, and there is some filter. So the filters are can be pretty much any filter, but preferably something HEPA or active carbon based. So we're using vacuum bags that are HEPA rated and just can be inserted into the filter tray and then inserted back on. The mask has several valves in it to allow for airflow to go through the front, going out and in through the filter, so that way it has moisture control and it does not, you're not breathing through your own filters. Otherwise, it just has elastic straps, and this can be replaced with string or whatever you have that will fit into these cantilevers. And yeah, and so this. We also are designing more comfortable head strappings similar to this one. And you can see they're fairly similar. It's a little bit smaller.
And describe what that is.
So this is a commercially available respirator that was partially the inspiration for designing this. And it's fairly comparable and in the feel and fit. And but this one's a little bit smaller, and also this can be printed in only about 3.5 hours with a little bit of hacking. On a standard printer with standard settings, you're looking at about 5 hours of printing. But it prints on any standard 0.4 millimeter nozzle 3D printer and uses the most commonly available materials, so preferably PLA, a very common 3D printing material, because if this contour doesn't fit your face perfectly, you can actually just soak it in hot water and then conform it to your face. And so you can get better air tightness on that. And The valves are replaceable, so unless you glue them in place, you can just take a screwdriver, pop off the retaining ring, and pop in new filters, or new valves if anything goes wrong. Otherwise, it's your pretty standard respirator. You can kind of see the valve working, and it's and they're quite durable. And the concept of these would be they're easy to deploy, they're quick to make, and they're semi-disposable. So anything breaks, you just print out a new one, and you can always change filters as they get dirty.
All right. Thank you, Rory. So this is really a draft video because our communication will be much stronger once we have validation from the medical community. Rory is graciously making this CAD available in an open source way so people can take it, modify it towards their needs, and distribute it broadly. And we hope to unleash, essentially the animal spirits of the hobbyist community in this country and other places. A rough estimate is that there's probably 1 million actively used 3D printers in America right now. So if you do the math and say a couple 100,000 of those start producing mass, you're producing upwards to 1 million masks a day. So any fraction of that is a good thing and helpful at this current time of crisis. So we hope this video has been helpful. Stay tuned for an update in a couple days, and everybody wash your hands and stay safe. Thank you.